Electric car batteries versus gasoline car battery. This is a lead acid battery. As you can see, the anode is lead, the cathode is lead dioxide, and it is in a hydrogen sulfide bath. Thus, it is exactly what it says. It is lead acid. This is the first battery made. It was made in 1899. It is also the heaviest. However, it can be said that with its age comes time for technology to create a better end product as time has gone by and the process of creating and also recycling these batteries have overcome the hurdles found in the manufacture of the product. This also means that they are the cheapest often and the easiest batteries to obtain, mostly because the process has become easier as it has been pared down from the complicated process of creating them that it was in the beginning. Now you will see that these batteries are used basically in gasoline powered cars for things like the starter to actually start the engine and for just some of the electrical components. And most of the batteries, electronics are actually used in the various accessories that come with the car, like anything powered windows, powered steering, powered doors, all of the different computer needs for the car. These are still, however, lead and acid. So lead is highly toxic. It actually can lead to memory loss and can actually make people dumber the longer they are exposed to it, which also doesn't help that gasoline also has lead in the fuel. And hydrogen sulfide is a very corrosive acid. Therefore, if the battery ever leaks or you have anything happening where the case is broken and the liquid leaks out, you have a very corrosive substance eating away at your car that is also going to be very difficult to clean up and replace. Some of the problems with the lead acid battery are also, besides the corrosive acid and toxic metal, is one of the byproducts of this reaction is water. However, you can have electrolysis of water with this very easily. Electrolysis of water creates H2O2, which is explosive. And therefore, lead acid batteries are vented to keep the H2O2 explosive content to the minimum. You can also have sulfation, which is where sulfate crystals start forming on the electrodes of the lead acid battery. This is a problem that is very difficult to resolve, and obviously since blocking the lead means that you cannot have the electrolysis happening. The lithium ion battery is the one that is currently highly in use today. It was developed in the early 90s. It is used in most electronic vehicles and other electronics, as it happens. Teslas are known to have the lithium ion battery. The cars use a high traction battery packs, which means that there are a whole bunch of batteries lined up along the bottom of the car, as I said when I was first discussing this. That also means that you have more bang for your buck, as all of these are individually completely sealed off. These do not need to be vented. They also do not have sulfation requirements. They have a high power to weight ratio, and these are also very light. Lithium is the lightest of the element metals, and so you don't have to worry about the weight except for whatever incidental other metals are added to the mixture, of which there are very many that have been used as people have been trying to find the right concentrations. Right now we have lithium manganese oxide, lithium iron phosphate, lithium tintonate, lithium nickel magnesium cobalt, lithium nickel cobalt aluminum oxide are just some of them. The equation in the slide shows one with cobalt oxide, and also what the reactions for overcharging and over discharging would have on the battery. These are cars can go longer, they have a higher energy capacity, they have a low self-discharge. However, there's also several bad things. They are sensitive to high temperatures at times. They can run hot. This is why they are also usually put in a cooling bath inside their structure, holding structure. And there's also the big problem that if the lithium-ion batteries are completely and totally discharged, they cannot be recharged. Fortunately, since they can be sealed around each other, that means that you can have extra batteries. So if you are driving and one of the batteries becomes overcharged or completely discharged, there are others to carry on, and you can get to your destination where you can replace the battery. However, that is also the fact that this is one of the newer technologies, which means it is expensive. It also runs cleaner, obviously, since you are not using gasoline to power the vehicle. You do not have an internal combustion engine driving the vehicle, so you do not have the byproducts of an internal combustion engine coming out of the vehicle, which means you don't have to vent anything. Electric cars have a great future. They are steadily improving on all of the negative aspects of them. They are quieter than gasoline-powered cars. They have a lesser amount of toxic chemicals that are directly in contact with humans and other wildlife. They are steadily becoming more powerful and also able to drive farther and faster than gasoline-powered cars, although right now their mileage is still being tinkered with. And they are also still mostly tethered to the electric grid and the power stations of this electric grid, which means that you are paying for fees of the electricity, which, while not currently that great compared to how high the gasoline prices are, since we are not using our own reserves, there are still fees that you have to pay. You also have to consider which mode of electricity generation the power stations are using, as not everybody is tethered to a station that is using environmentally friendly or friendlier, as it were, power sources. There are still a lot of power stations that are using oil or gas or coal versus the ones that are using hydroelectric or wind farms or solar powers, all of which still do have problems that have not been thoroughly thought out of by the environmentalists. Gasoline cars are toxic. there is lead in the gasoline, and currently prices are skyrocketing. So it costs $40 to get a tank of gas when it probably might not cost that much for electricity. But you have a lesser chance of having a problem where you can't get the gas. It is everywhere because gasoline cars have been in use for decades. So whereas you might have a problem if there is something that causes the electronics and the power stations to go down, where you better hope you powered up your car before the blackout or the storm or whatever took out the power station and your electricity, because otherwise you're not going anywhere once the power to your car runs out. And gasoline, you don't have to worry about that because the battery is pretty self-contained and it's not running the entire car. It's running the starter and the accessories of the vehicle. So there are different ways of thinking about this. Solid-state batteries are still in laboratory around the world. They are only in the last 10 years has this been possible. They replace the battery's liquid electrolyte with a solid material taking form of plastic polymer or compacted inorganic powders or a mixture of both. These are supposed to, in theory, have increased energy, density, and stability. They'll have more temperature control. They are hopefully delivering 2.5 times more energy. Comparatively, they'll be safer and more durable, less expensive, and compact in nature, so you can have more of these batteries in the car than maybe even the lithium ions. The recharge rate would be 4 to 6 times more than regular ones, which hopefully means you don't have to spend the entire night powering up your vehicle. They have greater electrochemical stability, so you won't have the problems that can come from reactions breaking down or just overcharging or undercharging, or the ones where you have problems with the discharging and then you can't recharge because you discharged it all. Unfortunately, these solid-state batteries are still in the testing stages, which means mass production